guys, what's up? This is me again. Let's move on with our bridge design course, and in this class we are going to discuss about the strand pattern. So you have to set how and the amount of cables that we are going to put on our girder, so how they are distributed over the cross section of our girder. Welcome to this class. So I have to declare the stress limit for our concrete, and this is the formula, the equation that we are going to use. O.19 square root of our F prime C. This is the tensile strength of our concrete. Here 7 ksi, the specified compressive strength of the concrete for the precast being at service loads. So this is the limit. The required number of strands are, we have to make the difference of the required stress at the bottom fiber minus the tensile stress limit for our concrete, this amount here, and this FB we calculated on our 9th class here, where we use the moments for the girder, the modulus section of our cross section, all right, the moment for the barriers, the moment for the wearing surface, and the moment for the load truck. Since our girder has a total or a overall depth of 72 inches, and we are assuming that the distance from the center of gravity of our strands and the bottom fiber of our girder is 7% of this overall depth. If we take 7% of overall depth of the girder, 5 inches, let me draw it in order to be clear for you guys. Let's say that this is our girder, a anchorage plate here and here, and the strands go like this, harped, and we have a line that connects sides of our girder. This is the eccentricity, EC, and this distance here is our YBS, all right? The distance from the centroid of our tendon and the bottom fiber of our girder. So our EC, 31.56 inches. What is YB minus this distance from the centroid of the gravity strands? We calculated that amount on previous classes, but you can also use a table for the girder. We choose a BT72, so YB is 36.6 inches. All right. The required precompressive stress at the bottom fiber of our beam is due to the PPE. What is PPE? The total prestressing force after all losses on our girder, right? The area of the girder, the modulus section, the eccentricity. So you got 4.3 ksi, but you have to find what is this total prestressing. So I solve it for the PPE. We found at the end of the day a number of 1,274 kips, right? So final prestress force per strand, the area of one strand times 1 minus all losses. So this is the initial strand stress that we calculate on previous classes here, assuming a final loss of 55% of this initial strand stress. So I declared here a variable, our PPE, the area of one strand. So the final prestress force per strand, the area of one strand times the force times 1 minus the final loss, 55%. We got a final prestress force per strand 23.23 kips. So the number of strands would be this force divided by force final. I rounded for a number that is multiples for 2. So the number of strands required, 56 strands. If we use a 1/2 inches diameter for our strands, and those strands have a 270 ksi of stress, we got the area of prestressed strands, the number of strands times the area of one strand. We will need 8.5 inches to the square. So I design it, I draw it here for you. 56 cables distributed over our girder, our Ashto PCI BT72. They are on this distance of 2 inches from the edges of our girder. So since we have 56 cables with this pattern here, where is the center of gravity of our pattern? So I declared here 2 matrices, one for the quantity of strands and one for the distance of those patterns, those rows of strands. Like here, the first row, 12 cables. The second row, also 12 cables. The third row, 10 cables. The fourth row, 6. And then we got this repetition for 2. Right? These are the distance that set on the AutoCAD software. The eccentricity would be the quantity of strands times the distance from the bottom divided by the sum of our 56 strands. You got 8.5 inches eccentricity. All right. So the strand eccentricity at midspan that I saw on the draw would be 2.653 feet. I got it in inches. Sorry, inches would be better. 31.56 inches. The distance from the centroid of our extreme bottom fiber. This is already calculated. So this is the end of our class. If you have any doubt, please leave a comment down below. I would be very pleasured by answering all your doubts. So guys, this is the end of our class. See you next time.